In this problem, we're asked to solve 2 divided by 5x equals x plus 1 over x minus 1. Again, the word solve here means to find all values of x that make this a true statement. So we're looking for numbers that make this left-hand side the same as this right-hand side. Numbers being possible values for x. And in general, when you've got a problem like this, you start looking for structure that'll help you determine the number of possible values and maybe give you a way to try and find them. And since this is equality, we have an equation here, not simply an expression. We can use some of the rules of algebra to rewrite this into a new equation that might perhaps be simpler. One possible approach here, and I'll discuss another one a little later on, one possible approach here is to eliminate the fractions by doing a cross multiplication. The idea here is that if I've got a over b equals c over d, then it must be the case that a times d must be the same as b times c. This is a cross multiplication, and it can be, this result can be generated by simply multiplying both sides of the equation by the denominators, and after those denominators then are canceled, you end up with this expression. And I'll show you how that works in detail as we write this one out. Again, you may be able to jump directly to this result, but I'm going to do it step by step. So I'm going to multiply both sides of this equation by the same quantity. That should preserve the equality, and the quantity I'll choose first is 5x. That will simplify this left-hand side, and I'll show you how here in just a moment. So I'm going to multiply both sides by 5x. So that's multiplication by the 5x, and on this left-hand side, notice I've got 5x times 2 divided by 5x. These two 5x's will have the same value, at least when x is not 0. And just a quick note here, x can't be one of our solutions. So I'm not really giving anything up here when I say x can't be 0. Similarly, x could not be 1 because of the division by 0 that would occur here. So I'm pretty sure, I am sure, that x cannot be 1 either. But this allows me to basically get rid of the number 1 that's sitting here, and that simplifies the left-hand side down to just a 2. And the approach then will be repeated to eliminate the x minus 1 term that's in the denominator on this side. So I multiply both sides of this equation now by x minus 1. And when I do that, I will see that there is an opportunity for cancellation that occurs as well. This x minus 1 that's down here will cancel this x minus 1 that's up here. Again, it's just going to create the number 1 whenever you have a value for x, and so they can be eliminated. That cleans up the problem considerably, although we're not done. It does write it as a simpler form that's easier to consider. We now have just polynomial forms on both sides, and again, when you've got polynomial forms on both sides, the approach is to get everything to one side and combine like terms, and then consider that new problem that comes out of that. So I'll begin by multiplying the 2 through here. 2x minus 2 is the result. And I'll do the same thing on the right side. 5x times x will be a 5x squared. 5x times the 1 is 5x. I'll now move everything to one side of the equal sign using addition and subtraction to combine like terms and to allow me to compare in the end with 0, which is an easier result. Again, our goal is to still find all values of x that now make this new expression a true statement. 2x minus 2 equals 5x squared plus 10x, or 5x, and it's not clear what values of x will make this true. But we're heading towards a form that will be easier to understand. So let's send these to the other side. I'll add 2 and I'll subtract 2x. So I'll have 5x squared, 5x, and I'm going to subtract the 2x, and I'm going to add the 2. And now since everything's on one side, the remaining side will be 0 now. And then I'm just going to combine these two terms so that they are easier to work with. 5x minus 2x is 3x. And so the new form I have is this. This equation has likely two solutions, one solution, or no solutions. That's the only possible list of outcomes. This is a quadratic form. And the simplest approach when it works is to factor this. Fill in these two blanks so that the product is this quantity. But try as you may, you're going to have troubles here. That doesn't mean that they don't exist necessarily, but it's not clear to me how to build that product so that we end up with the same problem. May seem a little frustrating, but in fact, we do have another approach that is guaranteed to work. It's the quadratic formula. The quadratic formula says that solutions to the form ax squared plus bx plus c equals 0, which notice that is the exact form of our problem, with a being 5, b being 3, and c being 2. The solutions to this will be minus b plus or minus the square root of b squared minus 4ac all over 2a. And when you're doing this calculation, begin with what's under the radical, what's under the root here. If this turns out to be a negative number, then there will be no real solutions because the square root of a negative number is not real. If this number turned out to be 0, then there would be exactly one solution to the problem. If this turned out to be positive, then by adding here you would get one value, and by subtracting you would get another, resulting in two solutions. So we're actually seeing the number of solutions through this formula. There's either going to be 0, 1, or 2, depending on the sign of b squared minus 4ac. So the first thing I would do is calculate that. And in this problem, again, the b is the 3. So I get a 3 squared minus 4 times a, which is 5, times c, which is 2, and calculate this number so that I can really check the sign of the value. We'll have 9 minus 40, which you can get the exact value, but